Here we're going to take a look at Go's map type. Now the map type is designed to hold key value pairs, and it's an unordered collection where each key must be entirely unique and comparable. Don't worry too much about the comparable bit, as we'll cover that later on in the video. If you've ever used Python, a dictionary is fairly similar, an object in JavaScript, or a hash map in Java, then you'll be fairly familiar with maps in Golang. So there's two main ways that you declare a map in Go. You can use the make keyword. So let's create a map here using the make function. So make, we define our core data type, our map. We then pass in the type of our key, in this case a string, and then the type of our value, in this case an integer. We can go ahead and print out this map that we have created using make, and we'll see we get an empty map in the output. So a map with no values in it. Another way you can do this is what's known as a map literal. To do this, you just create the type with, again, the type of the key, the type of the value. Let's just go ahead and add A is 1 and B is 2. We can then go ahead and print that out as well, and we should see that this map has the values in it. And we can see we get A is 1 and B is 2. Another thing to note with maps is that if you create a key without a value, it will always be assigned to a value of 0. So if we take our map literal here and go ahead and add in a new value of blah, if we go ahead and print out what a blah actually is, what A is, sorry, we will see that we end up with 0. Another thing to be aware of in Go is that if you use the var keyword to create a map, so we'll create a new map called nm for nil map, again, the syntax of key and then value, what you end up creating is what's known as a nil map. And if we look at the output here, we'll see it's fairly similar to the make output in that you get a map with no values. The core difference here is that when you use make, you end up with an empty map, whereas when you use this syntax here, you end up with what's known as a nil map. And we can demonstrate this with a quick example. So with our map made by make, if we go ahead and add a value to the key of A, let's just say 1, that will work absolutely fine. And again, we can print out that map. However, if we try and do the same with our nil map created using the var keyword, we will see that the compiler complains. And this is because we've created a nil map here and you can't assign values to a nil map. Okay, if we run this, we should see we get a panic, and we do. Assignment to entry in nil map. And you'll see that for the make map, we actually get the value as we would expect. So that's one thing just to be aware of. Basically, never use this syntax because you'll end up with a nil map and you'll end up with bugs and panics in your code. Always use either a map literal, like this, or use the make keyword to create a map. Now, when you use make, you can pass in a size or a capacity hint. And this basically just tells the compiler roughly what size to create the map with. However, because maps are dynamic and they can change in size, this is not a really strict thing. It's just kind of a quick hint to the compiler. If you add more than 10 items, the map will just expand to contain more than 10 items. Another thing to note with maps in Go is they are passed by a reference. So they don't copy, they pass by a reference. And we can explore this in an example now. So we've got our map literal here, which has A and B as our values, and we then have our nil map nm, which has nothing in it. And if we try and assign to our nil map, we end up with an error. However, because maps are passed by reference in Golang, what we can actually do is just assign the variable nm to equal our map literal. And if we go ahead and print out the nil map, we will see that that works absolutely fine this time, and we don't get any errors from the compiler, no panics. And you'll see we get exactly the same A and B, and then A and B as well. And that map is passed via a reference, so it's pointing to the same location in memory. It's not created a copy, it's pointing to the reference of the memory address. Mentioned at the start of the video that keys must be entirely unique in maps within Golang, and this is because if you try and use the same key to store a new value, it's ultimately going to overwrite that value of that key. So if we do this, we're going to see that A is now 100 rather than 1. And this is ultimately because under the hood, maps are implemented using hash maps in Golang. And when you create a new key like this, Go hashes that value, so it creates a unique string that represents the value of A. It then stores that in memory somewhere and assigns a value to it. So as soon as you try and use the A again, a key that's already been used, it's going to end up with the same reference, and it's just going to overwrite that bit of data. So one thing to be aware of, and I think this is pretty much the same in all languages, the keys must be entirely unique. We also said at the start of the video that the key within a map must be comparable. And what we mean by that is you need to be able to compare it with the double equals or the not equals. And because you need to be able to do this, there are some data types that you cannot use as keys, and these are slices, maps, and functions. And you can't use those as keys as you can't compare using either double equals or the not equals, as Go has no way to compare these values and check whether they are the same or not. So one thing that is a bit odd is that you can use an array as a key. I would never recommend this, and I've never seen it in any code myself, but if you want to, it's nice to know that you can do this. And if you go ahead and create an array here, we can create an array of integers to integers. We can create a map, sorry, where the key is an array and the value is an integer. And if we print this out, we will see that that works absolutely fine, and we end up with a nil map. Whereas if we were to do that with a slice, as we said, slices are not valid keys in Golang. So we create an empty slice of an integer with an integer like that. We're going to get an error here saying you can't do that because you basically cannot use that as a type. You see, invalid map key type of a slice of integers. It's one thing just to be aware of. More things that I want to cover in maps in Golang. So let's create an empty map here. We'll create it using the map keyword, make string, and an integer there. As we said earlier, when you create a key without a value in our map, so if we do A, what we'll see is that A ultimately ends up being defined as 0. If we run this code, we should see that we get 0 again, which is what we would expect. Now, there's another nice syntax that you'll see a lot in Golang code, and it's quite helpful to solve the problem of when you essentially create a key with no value, you ultimately end up with a 0 as the value. But how do you know whether you've explicitly defined that value as 0 or you've just not defined it and Go has defaulted to the value of 0? Well, you can use this syntax here. So let's go ahead and create B, and then we'll use the word OK, which is the kind of standard way of doing this. And we'll check our map here, and we'll do A. Doesn't really matter what we do there. If we print out B, and then we print out OK, we will see what we get here. You get 0 and the value false. And this basically means, has that value been explicitly set by us or not? If we go ahead and explicitly set that value, so we go ahead and do A equals 1, we'll see that we get back 1 and true in this case. If we even set it to 0, we will see that we get back true. And it basically tells you whether the value has been explicitly set or not. So it's a super useful thing to know. The useful thing that I want to cover is how maps are often used in the if block and the if condition. We've not covered those yet, but it's useful to know, and it's not too complicated. So with an if statement, you have your if, you then have some condition, and then you have your curly braces essentially. So like if 1 equals 1, you jump into your if condition, right? As we've seen with the syntax here, where you do the check for the value and then the OK itself, we can use that as our condition here. So if B, let's just change that to C. If C, we check whether it's OK or not. and then using a semicolon, we pass in OK after. So basically, if condition, then the value of that condition, we then jump into this code here, basically. So if we just go ahead and make this an underscore, and we can print out here, let's just print out in if block. If we go ahead and run that code, we'll see that we get in if block, whereas if we change this to be D, for example, which we haven't defined, in this case, OK is going to be false, and it's going to run into this check here, and it will not print out that particular code. So you'll see this syntax all over the place, and it's basically a shorthand way of checking whether something in a map exists or not, and it's very useful to use. So one thing to be aware of.